Question 6 should be 2y squared plus 4y. And then there's 3 more at the bottom. 8a squared minus 12a, negative 5 squared, and negative 9a squared plus 15ab minus 21a. Those are the answers to the questions you guys should have looked at yesterday. Are there any questions there that anyone would like me to demonstrate in more detail? Ethan, what are you doing with the giant can of brisk in your pen?
Trying to see how much I've drank.
Okay. Garrett, which one would you like to see? Question 8. I didn't assign it. No. There's an X through it. Are there any questions that anyone would like to see done from anything I assigned? Okay, Ethan, that's enough, buddy.
I sucked out all the air and then it shot a bunch in my mouth and then I kind of popped back up.
Yeah, put your can down. Are you on the right page? You are on the right page. Love that. Chandra, you feeling okay? We're good? Okay. As long as the not, yeah, we just one more. Okay. Okay. Yeah, the loose one's my original to photocopy. As long as I still got that one there. Nice. Did it go through? Impressive. Okay, so are there any questions from the ones that were assigned, Garrett, that you'd like me to do? Yes, Hassan. Harsh wants number 12. By number 12, you mean number 4 down here at the bottom?
Yeah.
Okay, let's do it. Okay, so monomial by polynomial multiplication means that we're distributing. Just like when we were subtracting, we brought that minus sign onto all of the terms and then grouped. This is similar. Instead of having the minus sign out front, now we've got a larger expression out front. I've got a 3a here. And then inside the brackets, I've got a negative 3a plus 5b minus 7. So what I want to do is I want to make sure that I multiply this monomial out front, the whole thing, 3a, onto each piece. For each one, I multiply the numbers first, the coefficients first, and then any letters. And if something doesn't have a corresponding piece, then it just comes along for the ride. So, for example, 3 times in the first one the first two things that we're going to multiply together, 3a times negative 3a, 3 times negative 3 is negative 9, and a times a is a squared. That's this first term here. Then we're going to multiply the 3a by the 5b. 3 times positive 5 is positive 15, so that's why this plus sign is here. And then there is no a to group it with. Oh, and just so we're clear here, the a times the a, it's going back to our exponent law stuff. When I multiply the same bases or the same variables, a times a, I add those exponents. A times a is a squared. These ones, a and b, are not like. They're different, so I can't combine them. But I can multiply them together. A times b is just ab. And then the last piece here is going to be the 3a times the negative 7. 3 times negative 7 is negative 21. So that minus sign has to go there. And then the a has nothing to group with, so it just comes along for the ride. Harsh, that makes sense? Okay. Anybody else want to take a look at anything else I assigned?
5.
Let's go over here. This guy? Or 5 on the next page? This page, okay. So, if we're doing 5, 5 is written backwards, but the procedure is the same. I take my monomial and I multiply it onto all the parts of the binomial. So I'll go the far one first. I'll work left to right here. 2x times negative 2x. Negative 2 times 2 is negative 4. So that's this piece. Then the x times x. When there is when you're multiplying the same letters, you add their exponents together. X to the 1 times x to the 1 is x squared. And then 2 times positive 3 is positive 6, so that's why that plus sign is there. And the x has nothing to multiply it with other than itself there. It's just kind of hanging out. So we bring it along for the ride, and I get negative 4x squared plus 6x. Make sense? Okay. Practice pages. For those ones, I gave them the extra practice questions that you circled in the book. Oh, from the previous lesson. Okay, cool. Did she show you guys? She must have, because she crossed a bunch of stuff out. You guys went through these questions. Part C. Miss S, do you remember if Miss Reed, she gave these ones?
Yeah.
Okay.
It was just the,
Yeah, she crossed off the binomial ones. Yeah. I did see, she didn't write anything on my original copy, I had originally written odds up top here, and she didn't, so I wasn't sure what she did with that.
No, she said all of them.
She said all of them, and then just crossed out these ones. Yeah, okay, cool. So that's fair. There was an answer key at the bottom for these ones, so that it's, not just super easy just look at. You actually have to turn the page and make an effort. Because I don't want you just, oh, what's this question? Oh, that's that answer. You actually have to, like, I don't know. I want you to actually do the question before you look at the answer. So anything I can do to make it a little bit harder to see the answers?
I
Use the answers?
No.
You cheated. Yeah. It's okay. You have a test coming up, and if all you do is look at the answers, it's going to go real well. Just super duper.
Yeah, super well.
Okay, so you had the answers to these. Does anyone want me to demonstrate how to do any of these? These were like the practice ones, but easier because they were all just binomials and monomial by a binomial. They were easier than the ones that were on the previous page. So if there are no further questions on these ones, sure, let's do 12. Dakota really wants to start dividing. Here we go. I'm just going to distribute in. That's the code word here, the keyword. This thing times, so this term, the 8x times the 2x, 8 times 2, Garrett. You bet. X times x, Garrett. X squared, x2, you bet. And then 8x times 6, you multiply the 8 and the positive 6 together to get positive 48, and the x comes along for the ride. That's it. Done. Easy peasy lemon squeezy. Okay, so flip ahead. We're going to look at dividing polynomials. Dividing polynomials is just like dividing anything else. And it's kind of like distribution, which you'll see here in a sec. So if yesterday's lesson was easy for you, and by all accounts, according to Ms. Reed's email at least, you guys seem to do really well with yesterday's stuff, so that's great. This stuff should be okay too. As long as you're willing to be deliberate with how you do your work, this stuff will be fine. We're going to look at dividing polynomials by monomials. And so, like, there are ways to divide polynomials by bigger polynomials. You are not going to look at that unless you decide you want to take, I think it's pre-calc 11. I think it's pre-calc 11 is the first time you'll see anything bigger than this. Yes, Hassan. It's page 7.
No, not showing the
Keep flipping. Keep going. It's like the last lesson. It'll be right near the back of the book. Yeah, it's very near the back of the book. Found it? Nice. Okay, so here is the method. So you got your multiplication. Adding was easy. We grouped like terms. Subtracting was slightly more complicated, but also rather easy. You were just bringing in the minus sign onto all the things, flipping the sign on the second set of brackets, and then grouping your like terms. Multiplying, you distributed things in. You multiplied the term out front by every term on the inside. And now we're looking at dividing. It's very similar. So here are the steps. I'll demonstrate them, and then I'll let you practice. What we want to do when we're dividing is Once we break this thing up, we're going to divide numbers by numbers. Obviously, we can't divide numbers by letters. So we're going to divide numbers by numbers. We're going to divide variables by variables. I'm marking your guys' exponent test, and lots of you did this question properly. Using Rule 2 from the exponent rules. Rule 2, for those of you who have perhaps forgotten, was that if I had some variable, let's go x, let's put it to the 6, and then I have x to the power of 2, and I'm dividing those things. I'll zoom in here so you can see easier what's going on here. If I have the same variable, and I'm dividing them, what do I do with their exponents? I subtract them. So this is going to give me x to the 6 minus 2, which is x to the 4. This is what we're going to be doing. We're going to use this guy here as well, this exponent rule. When I say, let's go back a step. When I say we're dividing numbers by numbers, if the numbers don't divide all the way, you still need to reduce. Again, I'll show you what I mean here. Reduce any fractions. Use our exponent law for division, which is when dividing powers with the same base, subtract the exponents. But I wrote out my example right there. And when you're dividing, underline this, you have to divide each term by whatever the denominator is. So here we go. Let's do a couple examples and I'll let you play. Here we go. I've got 8x squared divided by 2x. This is exactly the kind of question that I asked you in the exponents chapter. Hassan, did you need something from up here? You're good? Okay. This is exactly the kind of question I gave you out of the exponents chapter. What we want to do is we want to look at the coefficients first and we want to see if we can divide those. Can I deal with that 8 over 2?
Yeah.
What is it?
Negative minus 3. Divide by 2.
8 divided by 2 is? 4. No, we're not doing 2 divided by 2. We're just doing 8 divided by 2. Oh, you're reducing it that way. Okay. I was like, you can just do the division. Like a fraction, fractions mean divide. So if you see 8 over 2, like a fraction like that if you can, just divide 8 and 2. Because 8 and 2, they do divide. 8 divided by 2 is 4. We don't have to reduce the fraction there. It goes cleanly. So that's this piece done. 8 over 2 is 4. And then with these guys, we subtract exponents. When there is no exponent written, the exponent is a.
1.
So let's toss that in there. And then if I have x squared divided by x to the 1, that's going to be x to the power of?
2.
No.
3.
You said subtract, so subtract. What's 2 minus 1?
1.
So this is just going to be 4x to the 1, and when there is a 1 in the exponent, we don't have to write it. We can just leave this as 4x. That's it.
Oh, okay. I see what we're doing.
There is always a way to check. The check for this, if you want to go back and check your work, for those of you who like to do that, the check for this is to multiply the denominator by the solution. So our solution was 4x. So if I take 4x and I multiply it by our denominator, we should get the numerator. So you multiply the denominator by the solution, you should get the numerator. That's the goal. So if I want to check this, I take my denominator. Our denominator was 2x, and I want to multiply that by the solution we got. The solution was 4x. And your guys' multiplying apparently was really easy, so that's great. 2 times 4 is?
8.
Thank you, Ethan.
Oh my god.
X times x is? And is that what we started with before?
No.
In the numerator?
Yeah.
Yes, it is. So we're good. So this must be right. So that was a one-term thing. Let's look at a two-term thing. Let's make it more interesting. I have 8x squared plus 4x divided by negative 2x. So this is where the first one only had one term in the numerator and one term in the denominator. So this is where we need to use this third rule down here. You are dividing a binomial or a trinomial by a monomial. Divide each term with the monomial. So what we're going to do is we're going to rewrite this. We're going to split it up. Instead of 8x squared plus 4x all divided by negative 2x, it's kind of like distributing. We're going to take 8x squared and we're going to divide it by negative 2x. And then we're going to put the plus there because there's a plus there. And then we're going to take the 4x and we're going to divide it by negative 2x as well. Each term needs to be divided by the denominator. And then once you've separated like this is just two questions that look just like the first one. So let's look at each piece. What is 8 divided by negative 2? It is. Positive divided by a negative is negative, and 8 divided by 2 is 4. Good. And then x squared divided by x is?
Negative x.
Careful. We're just looking at each, right, because it's x squared divided by x to the 1. You subtract these exponents. 2 minus 1 is 1. So this is just going to be negative 4x to the 1. Before I do anything with this sign here, I'm going to look at what we've got here. I've got positive 4 divided by negative 2. Positive divided by negative is negative. So this is going to become subtraction in between these two terms. And then, yes, Dakota, thank you. 4 divided by negative 2 is negative 2. Yes, Hassan? No, you may not. I'm in the middle of a lesson. Now is not a good time to go. And then x divided by x, well, this is x to the 1 divided by x to the 1. Subtract the exponents. 1 minus 1 is?
0.
0. And x to the power of 0 is?
X.
It's not x. X to the power of Garrett? X to the power of 0 is 1. The x's are gone. This becomes negative 2 times 1, which we can just leave as negative 2. These go away. When you have the same thing in the numerator and the denominator, they cancel. And so now we can go back and we can check. If I take my denominator, negative 2x, and I multiply it by my solution, do I get the numerator? Well, let's distribute this thing in here. Negative 2 times negative 4 is? Positive 8. And x times x is? X squared. Good. Or x2. And now I distribute onto the second one. What's negative 2x times negative 2? Well, a negative 2 times negative 2 is? Positive. And the x comes along for the right. Is that what the numerator was to start with? Yeah, you bet it was. So because this is this, that means this is correct. Nice and easy, yeah? And that's it. That's all this dividing polynomial stuff is. The only other little snag I could give you is, well, let's take a look at it. I'm going to do this first question here, but we're going to change it. I'm going to put brackets around the numerator, and I'm going to multiply it by 2. If this was the question I gave you. This question is just a combination of what you did yesterday with this new stuff. So if I gave you something like this is I'm not going to use the word because Ethan doesn't like the word.
What is it?
Nope, not going to use it.
Polynomials?
Forget I said it. No, polynomials is great. What we want to do first is simplify the numerator.
Bedmass?
No, I never said it.
Oh, you said it was pop up in this book.
I never. No, this isn't bedmass. We're just simplifying. We're just simplifying the numerator, guys. We're just simplifying the numerator. That's okay. Wait till reverse bedmass next booklet.
What?
Now we're going to so by simplifying the numerator, I mean actually do this multiplication. Distribute this thing in here. What's 2 times negative 25? You betcha. And the x squared here just comes along for the ride. So 2 times negative 25x squared is negative 50x squared. And 2 times positive 15 is? You betcha, it's positive 30. And now I still have to deal with this division by 5. So in this first step, I'm going to break up this thing, and I'm going to make sure I divide each term. Remember, terms are separated by addition and subtraction. Each term is getting divided by the denominator. So it becomes negative 50x squared over 5 plus 30 over 5. I just kind of did that in one step. And now I simplify. Negative 50x squared divided by 5. I look at my numbers first. Yes, that is negative 10. X, yeah, thank you. And then positive 30 divided by 5 is? Positive 6. That's it. That's the only other thing I can do to make this more interesting, is to bring in something that vaguely resembles BEDMAS, but we're not going to talk about BEDMAS. And that's it. Today's lesson is short, which is good because it's Friday. Friday is a short block. That is my lesson. You may use the washroom, son.
Can I go?
Hold on.
No.
As Hassan's walking out the door, I will show you what I want you to do for homework. I want you to do all. Ooh, what's this? What? That's not that page. Am I missing a page? Ah, yes. I want you to do this page, all of it.
What if I just pay you in chocolate bars?
You don't have chocolate bars that are worthy.
I will give you a rock.
Lesson 6. I want you to do all of these as well. The division is quick. I think you're going to get a handle on this pretty good. And we will leave. Ooh, do we leave? Yes, there's 2 pages here. It says practice with 6 questions. I want you to do all those. Oh. This guy. Okay. Sorry, that was confusing. Yes, go back to the lesson page. I want you to do these bottom 3 that I haven't done yet.
Oh, no.
It's the same kind of stuff. Then I want you to do this page of 6. Dude, and I haven't answered you yet. Just wait, buddy. And then I want you to do this page of 8. Okay? And that's it. The chapter is basically done. At this point, it's just reviewing and extra practice. And you guys are going to have a test for me.
I want that extra practice. Give me the extra practice.
It's in the booklet already. You have it.
Yeah, you should go over everything. You know the multiplying thing that we were doing?
Yeah.
Post it on YouTube. I need it.
Okay.
Thank you. You're a man.
Why do you need it so badly?
Just gotta review it, you know.
Did you not do anything yesterday?
Oh no, I did all of it. I just need it.
Okay, well, on Monday we will do more reviewing.
Thanks, sir.
Or you could spend some time now practicing because Miss S and I are here to help you out. So, washroom people who asked in order are Hassan, who's out already, and I think Sahil was next. Sahil, you may go. When either one of those 2 gentlemen come back, Ethan and then Duden are going, but you gotta wait for some of these people to come back. Sahil, put your name on the board. Sahil, name on the board. So you have your task. Ethan, if you do desperately want more practice, if you flip again and it says more practice, it's right there. I also would love it if you passed. That would be, that's the goal. Okay, you have your task. On your market, set, go.